In C++, it's possible to take the address of a function and assign it to a pointer. This is called a function pointer. Function pointers can be really convenient in some circumstances, so let's take a look at how this works, and then we'll look at an example. So here I have a working copy of func.cpp from Chapter 2 of the exercise files, and we'll start by defining a function pointer. And then we'll use that function pointer to actually call our function here by putting fp there. So fp is our pointer to a function that returns void. And you notice this void type here is the return type of the function pointer. And that needs to match the return type of the function that you're assigning to it, because this function points to this function which returns void. And so when I build and run, you see that it calls our function through the pointer right here. So a couple of things you need to notice about this. First of all, like I said, this return type needs to match. If I were to change this to int, for example, you'll notice that we get an error. And if I click on that little red error marker, you notice I get an error about assigning a function with a different return type. And so that needs to be void to match the return type of the function that's being assigned to it. Also, notice the syntax of the function pointer. There's an asterisk in front of the token, the fp, which is the name of the pointer. And then there's parentheses around that, around the asterisk and the fp. Those parentheses are necessary because of operator precedence, and we'll take a look at operator precedence later in this course. But for now, just know that those parentheses are necessary. On the other hand, you notice the assignment, I'm not using the address of operator. You can use it, and if I save and build and run, you notice it works exactly the same. It's really optional here, and that has to do with how types are promoted in C++. And so just know that it works exactly the same with or without the ampersand. And the same is true here. You can put in an asterisk here for the dereference operator to dereference the pointer, but when you do that, you also need to put parentheses around the symbol and the asterisk. And again, you build and run, and that works exactly the same. And you'll see it done this way a lot. Actually, some people prefer this because they consider it more explicit, so that it actually looks like a function pointer in the code. And that's fine. You can do this either way, and it works exactly the same. So this is how you define and use a function pointer. Now let's take a look at this in practice. So we're going to go ahead and we're going to delete our working copy, and I'll run clean. And I'm going to take a copy of this jump.cpp, and we're going to look at that. So this is a simple example of what's called a jump table, where you have a number of functions, and you notice I have these functions named FA, FB, C, D, and E like this. And they're very simple functions. They're void functions that simply display a message. Each of these functions is on one line, and that's just for convenience for this example. In practice, they'll probably be very busy functions that do lots of things. But what we're going to do here is we're going to create a little menu, and you notice my menu here in these puts statements. The menu will display a bunch of choices, and you'll type in a number, and it will run that function. So let's just go ahead and build and run this, and you can see it in practice. And when I type 1, you see it says this is FA. And when I type 2, we get this is FB. And onward 3, FC, 4, FD, 5, FE. And if I type a 6, you notice it says invalid choice. And Q quits the program. So that's how it looks on the console when it's running. Let's take a look at what it does here. So first of all, you notice we have a couple of forward declarations for our prompt function and for our jump function. And then we have our 5 functions that are going to be used in the menu. And then each of these is put into an array of function pointers. So this is a declaration for an array of function pointers. And again, you'll notice the parentheses here because of operator precedence. That's necessary. And then it's initialized with this initializer list with the 5 function pointers, the address of our 5 functions, that's these 5 functions up there, and a null pointer to terminate the list. And that's just a convenience thing, and you'll see how we use that a little bit later. Then we have our main function, which calls jump and prompt inside of an empty while loop. And I'll show you how that works down below here, and then we put the string done for when it's done. So our prompt function puts out the strings for the prompt, and that displays this choose an option menu. And then we call fflush, and that has to do with flushing the standard out buffer. We'll talk about that later in our chapter on standard I/O. And then we have a buffer for our input and static storage for the response buffer, and fgets, which actually gets the string from the console. So when I type in a response to the prompt, that goes in a response buffer, and it comes from the standard in, and then we return the response. And so up here in main, you'll notice that prompt returns a constant character pointer, and jump gets called with the response from prompt. So jump down here, it takes that string, and it gets the first character from the string. So you remember in our chapter on arrays and strings, first element of the character array is the first character of the string, and that's all we're really concerned with here is the first character. When I'm running it, I can type a bunch of characters. It's just going to look at the first one. And if it's a queue, then it returns 0. And you notice up here we call this with a while loop, so when the while sees a 0, it sees that as false and it ends the loop. Very simple. For any other response, it comes down here, it gets the length of the array, so it looks for that null at the end of the list of function pointers, and when it finds that null, then it knows it has the last element of the array, and it uses that to count the length of that array of function pointers. And then this is just a little trick to convert the ASCII digit into an integer, and we decrement the integer because our list is 0-based, so when you type 1, it's the 0 element of the array. We check to make sure that we're inside the range, which would be 0 to the length of the array minus 1, so that'd be 4. And it'll put up the string invalid choice and return a 1 to continue the loop if it's outside of that range. Otherwise, it calls the function from the function array. And so here's our array of function pointers, funcs, and that was defined and initialized up here, right? It subscripts it based on our code that we typed, and it calls that function. Very, very simple. This is a very simple implementation of a really useful technique called a jump table or a jump array. So again, just in summary, we have all of these functions. We take the address of those functions and put them in an array, and we use that array to call whichever function is called based on the input from a menu. So I'll use this technique a lot in simple console programs that have a little text menu like this. I also use it in CGI or web services where, because the web is stateless, when somebody puts in a response from a web page, then that response, based on whatever that response is, we might need to call different functions. So I'll oftentimes use a jump table for something like that. So function pointers can be really useful. You're not going to need them often, but when you do, it's good to know how to do this.